Welcome to the MATLAB with Arduino tutorial. I have MATLAB up on the screen now, and the first thing we're going to do before we get started is we're going to go to our home screen, and if we have not done it already, we need to install the Arduino add-on. So at home, we're going to come across here, and we're going to go to the add-on section, these three little blocks. We're going to give that a click, and that's going to bring up our add-on Explorer. Might take a minute for this to load up. And we're going to come and search for add-ons. This is where we can install different packages and utilities for MATLAB. And I'm just going to do Arduino. And let's search for that. And this is going to bring up everything that has Arduino in it. Now I've already installed my MATLAB support package for Arduino hardware. What we're looking for is this package right here. Please do not get confused. There is a legacy package that we do not want and a simulate package that we do not need. So this is what we're looking for. We can click on the title here and it should bring us in. Here we are, MATLAB support package for Arduino hardware. I already have it installed, but you would have an install button up here. This is going to provide all of the commands that we need in order to interface with the Arduino. In fact, it'll even tell you all of the key features. It'll give you access to documentation, and you can even look at sample code. We're going to build some of our own sample code coming up in just a second, but once this is installed, we can move on to looking at our hardware. Okay, let's start building our circuit. We're first going to need to find our breadboard located in our Arduino starter kit. We'll set that aside. We're going to need 6 jumper wires, male on both ends. Assorted lengths are fine. We're also going to want an LED, color of your choice, but please note that there are 2 different pin lengths. We will want one 10K ohm resistor, so I'm just going to grab this and pull it free. We're going to need our potentiometer, which comes as 2 parts, this little ring and this shaft. We can put these together by picking them up and placing them like so, and now we have one nice little potentiometer. We're also going to need our Arduino board, and I'm going to set this aside for just a moment. Now, to begin building our circuit, the first thing we want is ground and power on these rails. I am going to pick a red and black wire for my ground and power. So I will do red and black, and now I have ground and power. So remember, on these edges, these are all connected in a row. Over here, these columns are connected. Each of these columns and each of these columns are separated down the middle. So now that I have this connected, I want to take my LED. We'll do this first. I'm going to put this in here. I'm going to keep track of which direction the long pin faces. That's going to be my positive. I might actually put it in like this. That's going to be my positive pin. And our Arduino is going to supply power to the LED, so we need to have a path back to ground. We're going to do that by taking our resistor. We're just going to bend the leads, and we're going to place our resistor in the same row as the short pin of our LED, and we're going to go right over to this ground side. So now we have LED, resistor, ground. And let's take our blue jumper wire here, and we're going to put our blue jumper wire on the positive side of the LED. We'll need that for later. Cool. Now we just need to wire up our potentiometer. This device has 3 legs. One goes to ground, one goes to power, and one is the leg that we are going to read from. And since we're going to read voltage, we'll put it in like so. I'm going to leave myself a little bit of room. Actually, you know what? I'll put it right across the middle. So I have some extra room. I'm just going to slide that in like so. So now I have this row. This will be going out to my Arduino. And then I need one of these. Doesn't really matter which one, but any one of these to go to ground. And I need to take the other one and go to power. So now I have power, ground, and my 2 extra leads. I'm going to bring my Arduino in, and we'll notice that down here we have a whole bunch of things that say 5 volt, ground, V in. We want to use the 5 volt in either of these ground pins. So we're going to take connect this to our ground pin. We'll connect this to our 5-volt pin, like so. So now we have voltage and ground coming from our Arduino. And now we just need to connect these up. This white pin is my potentiometer. I'm going to use the analog 0 pin over here. So I'm going to put that on analog 0. And then I want to use this digital 3 pin. So that's 0, 1, 2, 3. And it doesn't matter that these are the exact pins, so long as I'm on the digital side and I'm looking for that little squiggly that indicates I have a PWM pin. We can play with that later. All right, that's it. That is our entire circuit, completely built, everything we need to do. Okay, now that we're all connected and ready to go, we've downloaded and set up our little plugin here for the Arduino. I want to start by making a new live script. And I like to use live scripts. They're really portable and easy to use. And I'm just going to hit the new live script button. You can find it on the home tab up here. And that's going to bring us over to the live editor panel. And we have an area here where we can write some code. If you have the newest version, you might find that Copilot came installed with it. There might be a little pop out here. I'm going to hide that for now, not because I don't like Copilot, but I'm not ready to use that quite yet. All right, so first thing we want to do is always clear everything in our system, clear all of our workspace variables. It's a really good habit for all of your programs. So we'll just do clear. Great, clear. By the way, if you're not used to the tooltips popping up, you can tab through them. When you see the one you want, you can just hit enter or tab to accept. And don't forget, we just use our little dot comma there to suppress what we want. And you'll see that Copilot might try and pop up and give you recommendations. This isn't exactly what we're looking for, so it's kind of hard to trust Copilot. You can always come down here and sort of go in and adjust Copilot's chat settings, or you can come down here and just turn Copilot off through the setting menu there. I'm going to leave it on because every once in a while I like being able to ask a question. So the first thing I need to do is set up a way to connect to the Arduino. Now MATLAB's not loading code on the Arduino at all. It's just going to send a little package where MATLAB will communicate with the software running on the Arduino. The software running on the Arduino will send data back to MATLAB. So nothing we write will be on the hardware. All right, cool. How do I access this? Well, the command is Arduino. No capital, no anything. Connection to the Arduino and compatible devices. If you had multiple Arduinos, you could use Arduino list. I'm only ever going to have one plugged into my computer at any given time, so I'm just going to hit enter. Now, this Arduino thing is going to return back to me kind of a reference, we call it an object, to the Arduino. So I need a name for that, variable for that. I'm just going to call it my Arduino. And it is going to come back. So Arduino is going to go out, get a reference to my Arduino, and return that. And here, let me unsuppress this. We'll run it real quick, and I should see, after it runs for a second here, we're blinking, and yes, here we are. You can switch your output to view it side or inline if you like. Either of these are just fine, whatever you prefer. I'm going to toggle between the two as we write code, but sure enough, here it is. I did my Arduino, and it recognized that my Arduino exists, and here's all the information that I have available. All right, so let me put that back over on the side. So now that we have our Arduino, let's just do something. Let's do something really simple. Let's just turn something on. Let's just turn an LED on. So I have, let's see, we plugged our LED into digital pin 3, and we want to write, let's see, write digital pin. I'm just arrow down here, write digital pin, and then I have to give it something. Object, pin name, and value. Object is what your Arduino is. It's that data that stores where your Arduino is located. So we'll use my Arduino. pin, I plugged it into digital pin 3, and look at it's already starting to list all the possible choices. This is going to take in a text string that is D for digital and 3 because that's the pin number. So we could type that out if we wanted, but we have to put quotes around that. And then our value, 0 for off, 1 for on. So let me try this. We'll load this up. I'll hit run, and my LED should turn on, and it turns on. Nice. All right, I can set this to 0 and run it again, and my LED should turn off, and it's off. Cool. So we can write digital pins. Let's see if we can read. Let's see if we can read an analog pin. So, okay, cool. We'll read. Whoops, let's spell it right. Read. Oh, we can read a voltage. Read digital pin. Let's see, read voltage. Read voltage from an analog pin on Arduino hardware. Yep, sounds like what I want to do. And then, okay, my Arduino, sure, yep, I like that. And then the pin I used was a 0. So let's do this. And since I'm reading something, right, it's going to give me a number back. So I need to set that to a variable. So we'll use voltage. Always good practice to make your variable something that you understand, something readable. And actually, you know what? I'm going to unsuppress this. We can actually see what our voltage output is. It'll write it over here on the side. And I know that I'm connected to my Arduino, so I'm just going to suppress that output. And we'll run this. And this is going to read my potentiometer, and it's 2.9 some odd volts. I'm going to adjust this potentiometer a little bit. And now we'll run it again, and we should get a different number, 2.98. Now we're at 4.677. Cool. All right, so this is pretty easy so far. Now, let's see. Maybe what I want to do now is collect a bunch of data. So, and again, here's ChatGPT, or the version of it for MATLAB, trying to give me a hint. I don't really want that. It doesn't know what I want to do yet. So what I want to do is I want to collect a bunch of this voltage data, and then I want to plot my voltage data. Okay, well, I can collect data using a while loop. And while my condition, whatever it is true, I will be running inside of this loop. I need a condition, and usually while loops are really nice to have something that we can count, so we can count how many times we've been through the loop. If you design a while loop where you can't exit, that is a thing that MATLAB will totally let you do, and then you'll be stuck in the loop and you'll need to quit the loop. I can show you how to do that later when I inevitably make that mistake. I'm going to use I as my counter variable. It's just commonplace in the computer world, and I need to set what that's going to be equal to. You know what? I want a variable for my number of samples. I'm going to come right back up here, and I'm going to just make a little section that just says, I'll make a section here, and I'll just say user setup. Okay, user setup. And I'm going to do number of samples equals, I don't know, we'll do 10 samples. I can add a comment here. Number of samples. Cool, 10 samples. I'm just going to comment this out and move it out of the way for now. So we'll just cut that. I'm just going to tab went a little bit too fast there. I'm just going to come way down here with this, and I'm just going to comment this out and stuff this down here. Maybe we'll use this code later, maybe not, we'll see, but there it is if I need it. Okay, so while I is less than the number of samples, sure, it recognized that, then it will read voltage, and it will give me a voltage value. And you'll notice that while my while loop here is red, underlined, I need an end statement somewhere. Pretty easy thing to do. I'll just, look at that. It has an end statement, and look at it, it's recommending that we increment our sample counter. So this time, I'm actually okay with what this is doing because I can read it and I need to think about what it's doing, right? I want I to increase I plus 1. I want I to increase by 1 every time I run this loop. If I don't do this, then I never changes, and I get stuck in a loop, and that's no good. And it's also recommending end. So I can hit tab to accept everything that it's suggesting for me. Again, this doesn't always work, but on occasion, Copilot can save us some time. Okay, so I have this unsuppressed, right? I have this suppressed, so I should get voltage values, right, coming out of here for, whatever NS is. I think we have 10 samples. And let's just run this and see what we get. And I should get, once it's up, oh, there it is. See, look, it barely took a second. I didn't even have enough time to adjust to rotate my little potentiometer. It just, before I could even reach for it, it took all 10 samples. Well, it would be nice if I had a delay, right? If I had some way to pause my program. No, Copilot, that's not what I'm looking for. What I'm looking for is a way to pause my program. So I can use the pause command, and then I can kind of tell it how long I want to pause for. So I'll just say, like, I don't know, 0.02 seconds. We'll just do 0.2 seconds. Let's do 0.2 seconds. This is good. So I will just say, wait for the next sample, and I'm just going to remind myself that this is in seconds. In seconds. Cool. All right, so if I did this right, now when I hit run, I should have enough time to adjust. And yes, sure enough, there's my potentiometer values scrolling in on the right over here. Yeah, and you can see that they're changing as I'm turning the potentiometer knob. This is great, but what it's not really doing is collecting any data for me, right? Like, I would like to be able to analyze my voltage data later on. Maybe I want to write some filtering or do something later, like plot it. I could plot this, but I need to save that data first. So instead of having this just report back in all of my data, right, just print it all out, what I might want to do is maybe store this. And a good way to store this is in an array. So what I'll do is I will save a value, save a value, save a value. So each time I run through my loop, I want to make one step forward in my array. Okay, well, I can do that by just making the position in that array I. Remember, MATLAB always starts counting at 1. So array location 1, there's no 0, starts counting there. So I'll get location 1, location 2, location 3, location 4, so on and so forth all the way through. All right. Now, when we run this, we should be able to watch voltage expand. Actually, I commented this out, so let's just print our result down here. I'll just say voltage, and that should print out our voltage when I run this. Let me run it and see what we get. Oh, must be positive logical values. What does that mean? Well, let's hit explain error, and sure enough, it's going to come down here and it's going to tell us voltage I, read voltage, array indices must be positive values. Error occurs because I is not a positive number. Oh, well, what's I? Doesn't exist. There is no I. Okay, I know what I need to do. I need to come up here and I need to set I equal to, well, it has to be a positive integer, so we should always start maybe with I equals 1. So we'll always start with I equals 1, then we should go into the first spot, second spot, third spot, so on and so forth, all the way to NS locations. So let's try this again, and I'm going to hit start here, and I'm going to start adjusting my potentiometer knob, and we should be able to collect a bunch of data, and sure enough, here we go. Here's our voltage. I can hit these little double dots here and scroll through, and yep, there's me turning the potentiometer knob. So I've managed to store all of this in a variable, a voltage variable, an array, or a vector, because it's only one dimension, that has 10 saved points in it. All right, well, that's pretty cool, but maybe I want to, I don't know, adjust maybe how many samples I'm going to take. Oh, I know what I would really like to do. I'd like to adjust the time that I'm sampling for. Being able to sample things and record things for a specific time is really useful. So I'll make a sample time. Sample time. I don't know, we'll set that equal to 5 and seconds. Always good to know what your units are. And then I probably want a frequency too. How fast do I want to sample? That's a nice thing to adjust. Right now, I'm pausing for 0.2 seconds, but I like to be able to say, I want to sample at 90 hertz, 90 times a second. So sample frequency. And I don't mind making these really bulky variable names because I know that I have to just hit tab to complete them. So that makes life easy. And I'm just going to say 10, and we're going to put this in units of hertz. Again, always really important to throw your units in MATLAB so that you know what you did when you come back and look at your code later. Well, this is good so far. But what I really need to know is what this value that I wait, should be, right? So if I'm sampling at 10 times a second, how long should I wait between samples so that I get 10 samples in 1 second? And by definition, that is what the period is. So we should calculate a sample period. And this is pretty easy math, right? I want to calculate what that period is. I want to know in 1 period, right? What is that frequency? How many samples do I need to take? So this is going to be my sample frequency. So my sample frequency, 1 over my sample frequency is my sample period. I'm going to put this in here real quick so I don't have to see everything get reported. I'm pretty sure I believe that this math is going to work right. And I'm going to change this down here. Let's do this. I'm going to change this down here to my sample and sample period. Yes, please. Let's do that. All right, cool. I'm just going to run this. So we're still just taking 10 samples, but now I should be able to control how quickly we take those 10 samples. So if I set this at 10 samples a second, for 10 samples, I should sample at 1 second. So I need to be real quick with turning my potentiometer here if I want this to work. And all right, cool. And I can even look down here and see that my sample period makes sense, and that does make sense. And if I really wanted to slow this down, I could change this. I could play with this sample frequency value and slow this way, way, way down. All right, cool. But I have the number of samples. I have time and frequency. I have period. I want to know how many samples I need to take in order to take 10 samples a second for 5 seconds. And well, I guess I just did the math, didn't I? I said I want to take 10 samples a second for a time of 5 seconds. So what I want is I want to take, let's do this again, sample frequency, 10 samples per second, and I want 5 seconds. Sample time. So multiplying these two together should now give me the number of samples. Okay, so I should get 50 samples, 10 samples a second, that's 10 hertz. For 5 seconds, I should get 50 samples. So this, instead of being one row, 10 columns, I should have 1 row and 50 samples, and that should take me 5 seconds to collect. So it's going to be feels like forever. I always feel like when you're collecting 5 seconds of data, it feels like it takes forever to collect that data. Up, and there we go. And sure enough, we have a 1 by 50 here. I can click on that and I can scroll through, and you can see me changing the potentiometer values. I apparently maxed it out here for a little while at 5. All right, that's pretty cool. All right, what else can we do here, right? What else do we want to do? I know. Let's plot this. Let's just make a quick plot, and let's just plot voltage. So I'm just going to come down here and I'm just going to say plot, and I want to plot voltage. I'm going to backspace this just so it works out nice. Okay, plot voltage, and maybe this will give us a plot. This should give us a plot of what we have over here. Let's see if I get the plot command right. If I didn't, I can always ask for help. So I'm going to just spin the potentiometer down and then back up again and then down and up. Oh, I have to click the run button, I guess, down and up. So I'm just kind of moving the potentiometer around, and hopefully we get a plot when this is yes, and there we are. Look it, I can plot my potentiometer values. This is really nice. And let's spice this up a little bit. Let's just add some points so we can prove to ourselves we have some points on here. So the way we do that is we add these little single quotes, and it says line specifications, and I know that to get points I need star and I need a dash. And remember, if you're not sure what you need, you can always right click on plot and say help, and it will open up a little browser window with all of the possible configurations. Here, let's just do it. Boom, here we go. And it will tell you everything you could want to know, how to do colors, line styles, and then if you really wanted to know more, you can click on these examples like create line plot, and it will bring up a whole nother window. Let's just do it while we're here. It's going to do it in another monitor for me. It'll bring up a whole nother window. I guess I can't move it up. It'll bring up a whole nother window that will show you exactly how to use plot and give you some examples. So let's shorten this up. Let's do this only for 2 seconds because I don't want to wait. And let me pick up the speed. Let's do this at like 100 hertz. We're going to go really fast for 2 seconds here. And I will hit start. And I'm just going to adjust my potentiometer here. And then I should get a nice little plot with a whole bunch of stars. And sure enough, there we are. There it is. And look at this is nice. This is giving me my voltage, but it's giving me the number of samples. So this is plotting basically sample number. I'd like to see time down here. I want to know when those plots are taking place. And there's a couple of ways I can do this. I can add a time axis down here. I can try and scale that. But since we're writing a program, I like to keep everything kind of flexible up here. So here's what I'm going to do. I'm going to kind of set myself up for a user setup section. I'm going to end this section with just a couple of parentheses here. I'm going to do a new section here, and I'm going to do my code here. Cool. Okay, and then let's see. Yeah, we'll just say my code here, I guess. That'll work for now. All right, cool. So I want to add some time. You know what? I bet I can calculate my time right here. Let me calculate my time. I could say I'm just going to show you one way of doing this. There are better ways, arguably. Time equals whatever my time index is. So let's make this an array 2. So I'll make this an array just like voltage. And I know what I is. And then I want to, actually I don't want to add to that, do I? I really want to multiply that by my sample period. So if it's the first time in the loop, I know it's been this long. If it's the second time in the loop, I know it's been 2 times this long. So I will say times my sample period. Perfect. And I'm just going to put a little suppression on that real quick. So now I should have time. And let me run this. Something interesting is going to happen. Some of you might already see the mistake and might already have an idea, but we're just going to run this anyways and see what occurs here. And I'm willing to bet that time is going to look really strange when we're done running. Okay, so let's think about what's happening, right? I should have the same number of data points for voltage as I do for time. And time ideally will start at 0, and it will go to, let's see, what do we have? Well, it'll go to 2 seconds. So let's go and look at what time is, and I can click on time down here. Sure, great, cool, starts at 0, and it goes to, oh, I overshot there by a little bit. It goes to 200 here, wherever that's hidden. I overshot the first time, but not the second time. It goes to 201, we have one more data point that than what we actually need. And the question is, well, why is that? Well, if we stop and look, we're doing our incrementing before we're recording that value. And that's no good, right? That's not what we want, because now we're putting our first value, right, I, in position 2, not position 1. So it's position 1, position 1, 1 plus 1 is 2. So MATLAB is actually kind of tricking us, right? And it's putting in 0 for that first position when it's not really 0. So we need to do a couple of things here. We either need to move this down, or we need to figure out some way of subtracting off one value of I from the end. And this is, again, just one way of doing this. Another way of doing this would be to do, let's say I can come down here where I'm plotting, right? And I can add an x value. So I have y comma x, and I can kind of prove that to myself. Again, by right-clicking on plot and saying help on plot. Oh, look at that. Good thing I thought to check x comma y. So I want time. So I could do the same thing, right? I could generate this array of time either down here, or I could generate an array of time up here. I could say, you know, for time from 0 to ns samples, I can split that value up by multiplying by sample period. There's advantages to doing that. I've already written it in the loop here, so I'm just going to leave it in the loop for now, and we can fix this by either doing a couple of things, and this is going to be my trick. I always like putting, let me close this so we can see what we're doing. I always like putting this at the bottom of my loop. I always feel like that's the last thing we should do. Just, you know, maybe we have to do some extra gymnastics here, but it really helps to know that I'm not going to accidentally increment something somewhere in between doing some math. So it's just kind of a good practice thing, right? Like, this is a really good practice thing, and I'm just going to tab down or enter down here a few times just to give myself some room to work. So now when I run this, let's see what happens. Let's take a look. And do you think we'll still get 201? Well, let's find out here. And we're running. Nope, 200. Cool. So now we have time from 0 to 200. Oh man, see, look at this. We have time from 0.01 to 2. Okay, well, so I need to remember that this thing is going to be time shifted by 1 spot, right? So really, we're not counting from 0 seconds. We have to count that extra little bit of time that it takes at the beginning. And there are ways to fix this. We could do I-1 to correct our array. For right now, I think we'll be fine. Okay, cool. The reason I did this is because I want to be able to plot time, comma, voltage, right? Look at X, Y line. It tells me I can do more X's and Y's. Maybe we'll do that later. So let's see what we get now when we do this. I should get a plot that gives me some time here. So I'm just going to hit run, and I'm going to spin my potentiometer around a little bit while we're collecting some data here. And let's see what we get. There we are. Look, and now we actually have our time scale. So starting from 0 to 2 seconds here, we have this nice little, look at me moving this potentiometer around. Perfect. Okay, so what else can we do, right? Like, what else do we want to do here? What are we thinking? So we can add some logic. We can do some stuff like that. Maybe, and this could be real fun. So let's do this. Let's set this up. So we have some logic to turn on or off our LED. We'll use this digital right again, depending on a voltage threshold, right? We already know what our voltage is. So let's do this depending on a voltage threshold. Let's turn on or turn off an LED. So what I want to say is that if, I'm going to just tab in here a little bit to keep things cleaned up. So if my voltage, when right now, this iteration, if my voltage, this iteration is greater than or equal to, I don't know, I can make a threshold. Let's go up here. We'll add another variable here, voltage threshold. We'll make that one word, voltage threshold. I'm going to make that 3, and like I said, we always want to keep our units. MATLAB doesn't track that for us. We have to be smart enough to know what we're doing. So volts. So if our threshold is greater than voltage threshold, then what do I want to do? Well, I want to turn my LED on, and that's the LED we had on digital pin 3. So good thing I kept this, right? I just kept it commented out down here. I like to do that with code that I might or might not use, at least until I'm done, at least until I know what I'm writing here. So if that's true, I want to write digital pin, my Arduino. I want to turn that on. Now here's the thing, right? If I just leave it like this, and I need an end statement, and so if I do this, what's going to happen is I'm going to look at the voltage, I'm going to calculate my time, I'm going to wait my sample period, and then I'm going to check my voltage threshold. If it's above my threshold, if my current voltage is above my threshold, I'm going to turn the pin on. But what if it's below the threshold, right? Like, what if it goes below the voltage threshold? Then maybe what I want to do is I want to turn this pin off. So let's do an else. So if that's true, else if not, look at Copilot's got my back this time. It's suggesting to turn it off. Yeah, that seems pretty reasonable. So, okay, if it's above my threshold, turn it on. If it's below my threshold, or if it's at least not above it, any other condition, then turn it off, and then we'll increment ourselves, and away we go. Okay, let's give this a try. I'll hit play, and as I turn my voltage knob all the way up, oh, there we go, my LED is on, turning it down. Look at that, I can completely control my LED. That's pretty awesome. And then this will also produce my plot for me after we run here. There we go. There's my plot. This looks great. But there's one more. There's one problem I have, right? I would really, really like this to... But there's one problem I have here. I would really, really like this to be able to like update, to plot in real time. This is one of the really fun parts about being able to use a live script. So the live scripts, I'm just going to cut this sucker here. I'm going to jam it up here. I'm going to paste it. And I'll just hit tab once so everything's lined up. It just makes life easier to read, right? So here's what I'm going to do. I'm going to plot time versus voltage. So let's just try this and let's see what we get from the plot, right? Let's see how this looks and let's see what happens. And I'm actually going to put this in an inline view this time. Let's just watch what we get. So I'm going to hit run and oh, look at that. Isn't that really cool? You can see that line going up or down. There we are. I'm at 5 volts. Now my LED is off because I'm below it. And I can actually track in real time what's happening with my signal, right? There it is in real time. And this is also super cool. In live scripts, I get this little playback bar. I can hit play and it will replay what I did. Or I can grab this and I can kind of scrub over to where I'm interested. Oh, look at that. That's really neat right there. I like that part. Or I can adjust my playback speed. Maybe I'm too used to watching TikTok videos. I have no patience. So we'll do it at double speed. There we go. Or I can even slow this down if I'm really interested. You know, this part's where things got interesting, right? Maybe right here. I want to see this up close. I'll slow it down a little bit. I'll hit play, and now I can watch this, really slow down. And notice that my time axis is still my time axis, and even though I'm slowing down my playback, I still know where I am relatively in time. I can also export this little animation. I can click that, and I can get a little exporter, so I can export all of the graph as like a little MP4 file. I also can use a figure, and I can generate axes and titles. I would do that up here if I were going to do it. Generate axes and titles for everything that I'm looking at. And this is just a really basic example of how we can collect some data, process that data, and display that data both in real time, and then we can hold that data to do something else with later. Actually, you know what? Let's do it right now. Let's, instead of later, let's find the average. Let's see what our average signal was. Average voltage. Our average voltage was, and I'm just going to do sum of, what was our array here? Sum of voltage. And let's divide that by the number of samples that we took, right? Because that's literally what a sum is. I'm going to leave this unsuppressed so that it will output our average voltage. So I can grab the knob, and then I'm just going to start just like sort of adjusting this around here. Maybe I'm going to try and make like a really crude sinusoid. Look at that. Isn't that good? So there's my awful sinusoid, and I'm almost done here. And there we go. There's my horrible sinusoid, and I have an average voltage of 2.4 volts. Awesome. It is as easy as that.